Cool.
Awesome. Yeah, hello everyone. Happy to be here. This is my first ever NG Rome. This is fantastic. So I'm joined by my partner in crime and signals, Pavel Kozłowski. And we're here today to answer kind of an interesting question. Pavel came up with the title for this talk, I think with NG Rome in mind. Quo vadis, like where are we going? And this is kind of an unusual talk for us. Quite often at conferences, especially in keynotes, we're talking about the things we've done, right? The things we've launched, the new features that are part of new releases. We're going to do something different here. We're going to kind of look in the crystal ball a little bit and look forward and see where is Angular actually going. So that means we're going to be very honest with you about the direction that we see the framework taking. And that comes with a little bit of uncertainty. So just remember all of the priorities, the designs, the kind of direction we're talking about. Things can change as we learn new things and as the web evolves. So earlier this year, people started noticing that something was going on with Angular. It kind of felt like the team just woke up and got to work. So what's actually happening there? Is there something big going on? And it turns out there's actually two things that make right now a really unique time for Angular. The first is that we're actually in a really healthy place as a project. We have a fantastic team with excellent leadership. We have a code base that's very healthy that allows us to kind of experiment and innovate very quickly and iterate on new ideas. And the second thing is that we've actually been around for a while. Angular 2 is 8 years old. We have years of experience building this thing and 8 years of feedback from developers like yourselves. Um, we also have 8 years of experience seeing where the web is going and how other frameworks are tackling some of the same problems. And that's a privilege and a really significant advantage, actually. There aren't many web technologies that have been around for that long and have that much history. So we're in a strong position right now to innovate and evolve the framework, which brings up a question, like where do we go? What do we actually do with the knowledge and the capacity to innovate that we have? And to answer that, we asked ourselves kind of an even more fundamental question. What guides our decision making? What do we actually care about? How do we decide what problems are important to focus on? And I think if we talk to anyone on the team, they'll give you a different answer to that question. But as we went through this exercise, we came to realize that at heart, all of our motivations shared a single core focus, that we value your time and your energy. And we think you should be spending that time and energy building the products that will delight your users and not on micromanaging or babysitting the framework or trying to figure out how to get Angular to do what you want. So looking at our future through this lens of valuing your time and energy, we see three big opportunities in front of us, three areas we want to focus on, and we'll dig into them today. That is how we can make Angular a capable tool for building great user experiences, how we can shape it to have a first-class, excellent developer experience, and how we plan to invest in the framework's future over the long term. So let's dive into that first opportunity. Let's talk about the user experience of Angular applications. And we think that building a great user experience should require a lot less work than it does today. And this is not a statement about Angular, actually. We think this is true on the web in general. We don't think this is a solved problem. Part of the challenge is that the bar for what constitutes a great user experience keeps getting higher. Core Web Vitals sets this goal of 2.5 seconds for the largest contentful page, basically the initial load of your application. And that's a very unforgiving target to meet. And to meet that target, developers have to juggle a lot of different technologies. You have content delivery networks, edge computing, kind of backend RPC frameworks, et cetera. The more we can do framework to handle those concerns for you, the more of your time and energy you'll be able to spend on shipping features instead of optimizing for initial load. And we call this strategy performance by default. And it has kind of two prongs. The first is that we just want to make it hard for you to write code that doesn't perform well. The framework should guide you with its API designs, with its feature choices, with guardrails, so that you don't accidentally create performance problems in your applications. Secondly, you shouldn't have to worry about hand optimizing things and keeping up with what the kind of current state of the art is for a fast user experience. Angular should be able to do that for you behind the scenes. And you can already see these principles in action in some of the features that we've shipped in version 17, for example, with the new control flow. So with NG4, one of the things we saw is many developers would not include trackby in their NG4, either because they forgot that it existed or didn't realize the impact on performance that it might have for certain situations. And so with the new for block in control flow, we've made track expressions not only easier to use, but also required so that you don't accidentally fall off this performance cliff. Here's another example. If effects, the new effects in Angular are mutating signals, that can lead to kind of inefficient update paths where we have to render things multiple times. So effects don't let you do that by default. You can still choose to opt into it. We don't want to take capabilities away from developers. We want to make it easier for them to kind of do the right thing and be aware when they're risking doing something that might cause issues. On a bigger scale, one of the many projects that we're working on, one of the main projects at the moment, is support for zoneless, running Angular applications without Zone.js. Zone has been a big part of Angular for the last 8 years, but in that time, we've started to see some of its critical deficiencies. It's a non-trivial amount of code to load. It has a tendency to overreact to things, and it's not giving us the kinds of informations we want to optimize applications at the level we'd like to do. So Zone is about 35 kilobytes, which gzips down to roughly 12. It's a non-negotiable startup cost. You're paying that every application load. Angular is then using Zone to drive change detection in response to something happening on the page. So set timeout event fires, user clicks a button, etc. Angular does its thing, updates the application under the assumption that you might have changed something in the UI that needs to be refreshed. But that's not always the case. Not every interaction in the browser results in a state change that needs to be change detected, but Angular doesn't actually know that. So this is a modified version of a fairly optimal Angular application. We've added logging to each change detection cycle so we can kind of see how often. As you can see, this application is doing like 100 change detections on startup. There are many ways you can accidentally get into this situation. And Zone kind of doesn't give you any warning that this is going to happen. And that's because Zone doesn't really tell us what has changed in the application, only that something might happen. We're kind of forced to assume the worst in that sense. Then Angular is going to do this global operation, walk through the component tree, and verify that the whole UI is up to date. And many developers today optimize their application with on-push. They keep specific components and opt them out of this global change detection flow and say, no, Angular, I will tell you when this specific thing needs to change. You don't have to check it every single time. But that's the kind of hand optimization that we want to avoid. We don't think developers should have to focus on making sure their components are going to stay performant as their application scales. So we've been looking at ways we can do better, and that's where signals fit into this story. There are two things that we're getting from signals that we're not getting from Zone.js. The first is this positive indication that something has changed. When you update a signal and you're using that signal in your template, Angular doesn't have to do any guesswork. It doesn't have to make any assumptions. We know that UI needs to be refreshed, and we can kind of avoid overreacting to events that don't happen to change state. And the second thing is we know exactly which components are affected by that change. And that means we don't have to go through this top-down global update process. We can target the update specifically to the components that need refreshed and no others. Then you start to see some of these optimizations in version 17. Components that are inside of on-push trees that become dirty through signals don't need to change detect their parents. That's something that the previous kind of on-push mechanism had to do. We can check those components directly, as well as any children that might depend on the new state, right? I think the community termed this local change detection. We think that's a good start, but we want to go further. If we feel that your templates only depend on signals, optimize even more. And we can check individual views, or even if it made sense to do so, individual findings. And this is the idea behind the RFC, what we call signal components. Components that know that signals are the only way that they depend on state. In the signal components, we could do even better and target changes to whatever granularity happens to make sense. That lets the framework optimize for you under the hood without you having to kind of give us the information for every single thing that you're using. And improving this change detection performance really helps. But to optimize the initial loading experience, we need to do a few things more. There are kind of two obvious solutions to this. Either load less code and make the framework smaller, or make the code that we do load more efficient, make it run faster. Making zones optional is a great example of kind of making the framework smaller. We get rid of that 12 kilobytes. The new control flow also does this. Using just the new for blocks and if blocks instead of ng-for and ngif will save about 10 kilobytes that would almost certainly end up in your initial bundle otherwise. And we've made the control flow faster. This rainbow here is the big green table. This is a benchmark that framework authors use to track performance of different frameworks with different rendering tasks. And our new for loop implementation actually addresses a longstanding inefficiency in ng4. So this is Angular as of version 16 using ng4. And we don't look so great on some of these benchmarks. And this is just due to how ng4 list diffing was implemented, kind of something that landed in version 2.0 and was not really updated since then. And the new control flow actually alone moves us a significant distance to the left in this table. There's some tweets about the kind of comparisons with different frameworks, and we won't get into it here, but Angular is looking pretty good in this sense. But there's only so much smaller and faster we can get, right? When we start removing that much code, eventually you have to start removing features. You can't have a framework that has all the options and not have the code that support it. So one thing we can do is actually make the framework smarter to kind of maybe not load everything at once, but be able to load things over time. That means doing less work in the critical path, right? That LCP path on the initial load, usually by pushing the work to the server or doing it later on the client. And often we'll employ this strategy kind of simultaneously on different optimizations. So not surprisingly, server-side rendering is a big part of this story, right? If there's work that you can do before you get to the browser, it makes sense to usually do it there. We've been working on making SSR kind of more streamlined and easily accessible in Angular. You've already seen us take Universal and incorporate that into the core framework. We've optimized SSR to run in more places like edge computing environments. But we have a few bigger projects on the horizon, kind of aimed at the integration of server-side rendering and the initial load optimization. So let's talk about a few of them. And these are kind of investigations. These are not fully designed features. We don't know if these are going to ship or not, but these are things we're kind of experimenting with to see if they move the needle significantly enough for us to invest in actually delivering. So one such project is streaming, right? Today, server-side rendering in Angular behaves much like a client-side rendering. You bootstrap the application on the server. There's some kind of DOM tree that's getting created. And when the application is stable, whenever all the data fetches are returned, when everything renders, then we kind of snapshot that DOM tree, turn it into HTML, send it to the client. With more granular information about which parts of the application are ready to render, which have received their data, we can start sending HTML before all the data fetching has happened on the server, and kind of optimize this process so the server is still loading data while the browser is able to start rendering. Event delegation is another interesting technique that we're looking at. That's where we use a kind of single global event listener instead of an event listener on every element that you declare kind of an event binding to. This has benefits like eliminating the cost of registering those listeners. That's something that's kind of traditionally slow in browsers. But it can also help make the page more interactive in cases like hydration. So another technique that we're looking into is something we call partial hydration or progressive hydration, depending on which definition you read. We think that can be a really valuable optimization, where coupled with APIs like we have for the defer block, you can declare that a part of your UI is not critically important during the initial load, and Angular can actually leave that code unloaded until the user starts interacting with it or until it ends up in the viewport or some other trigger like that. And in all of these investigations, we actually have kind of a partner behind the scenes. There's a team at Google called Wiz. They build a framework that's used in some of the largest Google products, including Google Search. And they have 10 or so years of experience using these techniques in production in some of the kind of the biggest and most performant applications at Google. Wiz is the framework that inspired a lot of interest in techniques like resumability that have been explored a lot recently. And in particular, they're really knowledgeable about where these techniques make sense, where they provide benefit, and where the cost is not necessarily worth the benefits that you get, where the trade-offs don't really make sense. So having the technical capability to optimize these things is essential. But what's equally important is making those optimizations accessible to you as developers, making it easy for Angular to do them for you without you having to kind of micromanage what's going on. For example, a common technique, common optimization is lazy loading components. And that's been possible since about version 9 in Angular. You've been able to load a component independently of the router and instantiate it somewhere on the page. But it's never been very easy, right? It's kind of a bit of boilerplate involved to loading this thing, creating ng module associated with it, etc. Instead, we've shifted to kind of building APIs that try to capture your intention, right? Not your intention translated into unrelated framework concept. Then the framework can actually do the heavy lifting for you. And in many cases, as these new APIs become available, we can actually do different optimizations behind the scenes because you're giving us information about what you want to achieve, not necessarily hard coding to the framework how you want to go about achieving it. So to optimize lazy loading in Angular 17, we introduced the defer block. And the defer blocks don't require writing any dynamic imports or callbacks or kind of promise chains to go and create this. They don't require you to interact with the container. Instead, you declare to Angular what's important to you as developers, which parts of your template you want to kind of defer loading, and when it's important for that content to be present. And then the framework can handle the heavy lifting behind the scenes. So the next kind of thing we wanted to talk about beyond user experiences is optimizing the framework developer experience. And I will turn it over to Paul.
Thanks. So